Hello students, in this video lesson we will study about the types of chemical bonds. When a chemical bond is formed between the atoms, then both the combining atoms acquire the stable inert gas electron configuration. There are two types of chemical bonds which we have to study, ionic bond and covalent bond. We will now discuss about ionic bonds in detail. Children, please note that ionic bond is also known as electrovalent bond, as there are electrical charges on the atoms involved in the bond formation. The chemical bond formed by the transfer of electrons from one atom to another atom is known as an ionic bond. The transfer of electrons takes place in such a way that the ions formed have the stable electron arrangement of an inert gas. The ionic bond is called so because it is a chemical bond between oppositely charged ions. An ionic bond is formed when one of the atoms can donate electrons to achieve an inert gas electron configuration and the other atom needs electron to achieve the inert gas electron configuration. Now, we know that the metals have usually 1, 2 or 3 electrons in their outermost shell which they can donate to form stable positive ions, and on the other hand, the non-metals have usually 5, 6 or 7 electrons in their outermost shell, so they need electrons to form stable negative ions. So, when a metal reacts with a non-metal, transfer of electrons take place from metal atoms to the non-metallic atoms and an ionic bond is formed. In the formation of an ionic bond between a metal and a non-metal, the metal atoms donate one or more electrons to the non-metal atoms. By losing electrons, the metal atoms form a positively charged ion called cation, and the non-metal atom accepts electrons donated by the metal atom and forms a negatively charged ion called anion. The positive ions and the negative ions attract one another. The strong force of attraction developed between the oppositely charged ion is known as an ionic bond. The compounds containing ionic bond are called ionic compounds, which are made up of ions. We will now describe the formation of some ionic compounds such as sodium chloride and magnesium oxide. So let us study about the formation of sodium chloride first. Now we know that sodium is a metal whereas chlorine is a non-metal. So sodium metal will react with chlorine to form an ionic compound, sodium chloride. The atomic number of sodium is 11, so its configuration is 281. Sodium atom has only one electron in its outermost shell, so it will donate its electron and form sodium ion, which is Na positive. The atomic number of chlorine is 17, so its electronic configuration would be 287. Chlorine atom has 7 electrons in the outermost shell and needs one more electron to achieve the stable 8 electron inert gas configuration. So, a chlorine atom takes 1 electron from the sodium atom and forms a negatively charged chloride ion, Cl negative. So, when sodium reacts with chlorine, it transfers its one outermost electron to the chlorine atom. By losing one electron, sodium atom forms sodium ion, which is Na positive, and by gaining one electron, the chlorine atom forms a chloride ion, which is Cl negative. Due to opposite charges, sodium ions and chloride ions are held together by the electrostatic force of attraction to form sodium chloride. In sodium chloride compound, the electronic configuration of sodium ion 2,8 resembles that of inert gas neon and the electronic configuration of chloride ion 2,8,8 resembles that of another inert gas, argon. Due to this, sodium chloride compound is very stable. Let us now discuss about the formation of magnesium oxide. Now magnesium is a metal whereas oxygen is a non-metal. Magnesium metal burns in oxygen to form an ionic compound, magnesium oxide. The atomic number of magnesium is 12, so its electronic configuration is 2,8,2. We see that magnesium atom has 2 electrons in its outermost shell. So, the magnesium atom donates its 2 outermost electrons and forms a stable magnesium ion Mg2 positive having the electron arrangement of neon atom. The atomic number of oxygen is 8, so its electronic configuration is 2,6. We find that oxygen atom has 6 electrons in its outermost shell, so it requires 2 more electrons to achieve the stable 8 electron structure of an inert gas. Thus, an oxygen atom accepts 2 electrons donated by the magnesium atom and forms a stable oxide ion O2 negative having the electron arrangement of a neon atom. So, when magnesium reacts with oxygen, the magnesium atom transfers its 2 outermost electrons to form an oxygen atom. By losing 2 electrons, the magnesium atom forms magnesium ion Mg2 positive, and by gaining 2 electrons, the oxygen atom forms an oxide ion O2 negative. Oppositely charged magnesium ions Mg2 positive and oxide ions O2 negative are held together by a strong force of electrostatic attraction to form magnesium oxide compound MgO. Let us now study about some properties of ionic compounds. Ionic compounds are usually crystalline solids because their oppositely charged ions attract one another strongly and form a regular crystal structure. The ionic compounds have high melting and high boiling points. Why? Because there is a strong force of attraction between the oppositely charged ions, so a lot of heat energy is required to break these forces of attraction and melt or boil the ionic compound. The ionic compounds are usually soluble in water but insoluble in organic solvents like alcohol. The ionic compounds conduct electricity when dissolved in water or when melted, because there are plenty of free ions in the solution or in the melted form which are able to conduct electric current.